So today is lesson 12. It's our last lesson of this semester. Wow, it flies by. So I've gotten, I believe, 28 of 36 submissions for assignment 2. So if you are one of the 8 students who hasn't yet submitted, then please make sure you submit today, Monday, to get the most marks possible. So today we're going to talk about next week's final exam. And then we're going to dive a little bit into kind of at a high level. We're going to talk about APIs. We're going to implement a couple simple APIs. We're going to integrate some third-party code into our PHP Flix application. And then we're actually going to create our own simple API. And this is going to be an introduction. We're going to work with APIs a little bit today, but we're going to see them again. So you're going to work with APIs next semester in your ASP.NET class, and you'll also work with APIs later on in your Mean or MERN, your JavaScript frameworks or advanced server-side scripting class. So APIs are something that web developers work with a lot. So we're going to do kind of a light introduction today, but I do want to just talk about next week's exam. So I think I discussed this already, but the format of next week's exam, it's all practical. So it's similar to the midterm, but there's more coding, there's more pages you'll have to write, and there are no multiple choice questions. The entire exam is a practical exam. There will be multiple versions of the exam, so each student will randomly be assigned to complete one of the 3 exam versions. They'll have similar types of requirements, but they'll be done in different ways. You must complete the exam that is assigned to you based on your student number. So you cannot submit a different exam and be marked for it. Hamid, do you have .NET with me? It depends on which program you're in, because the students in this class, about half of you are in interactive media web, and about half of you are in computer programming. I will be teaching ASP.NET in September for the web students, as well as for the Lakehead degree program. But I don't believe I have any sections of ASP.NET for computer programming. So to me, it depends which program you're in. Are you in web? Yes. So if you're in web, we're going to be together for ASP.NET in September. And we will be together twice next January, once for advanced server-side scripting and another time for Project Studio. We've got a lot of time left together if you're in the web program. Sorry, I will go back to the exam. Andres, great question. The exam will be 3 hours. So it will be the same as class time. I will be sure to open up the WebEx room by 7:50. The test will be available right at 8 a.m. and I will go over the instructions at 8 a.m. I'm only going to go over them once. So if you come late, you will miss the instructions. You must submit by 11 a.m. Okay, and the format for submission, just to keep things simple like the midterm exam, you will not have to upload your pages to AWS. You can, but you can change your AWS server after the end of the exam. So I'm just going to mark what you're just going to zip and upload to Blackboard. And I will download everybody's files. That way there's no possibility of somebody trying to change their file after the end of the exam. So I'll remind everybody around 10:50 or 10:55 to stop working and zip up their files and make sure they upload, because the exam will close at 11 a.m. So in terms of fairness, everyone has to submit within the same time window of 3 hours. Well, there are no code questions. There are just a series of programming requirements. There's no question and answers at all. I will just give you a list of requirements. I will start on assignment 2 either today or tomorrow. Can't give you an exact date of when they'll be finished, but they'll be definitely marked before the weekend, like Friday at the latest. I would say Thursday at the latest. for your assignment, 2 marks, depending on how it's going, depending on how the week goes. Yeah, probably Thursday, sometime by the end of the day, Thursday is my goal. I should be able to start on them today. I have a little window tomorrow, but I've got a busy Tuesday, busy Wednesday. So realistically, in terms of expectations, I'd say I should have them finished by Thursday, certainly before the weekend. So you should know, and I will also enable on Blackboard your current weighted grade. So you will know going into the exam exactly what your grade is in the course. Okay, you'll be able to see that on Blackboard. So Sarah, so similar kind of like to a briefer version of your assignment. Yeah, could be. So, and it will focus primarily on the things we've covered in the second half of the course. So there'll be, not entirely, but more of the marks are on things like authentication, file uploads, APIs. That's more of the grade than things we did in the first part of the course. Tyler, there'll probably be a few pages. It won't be all on one page. There's too many different requirements. So you'll have to make several different pages. But yes, Sarah, it won't be the same scope as your full assignment. Like obviously, what I asked you to do in 3 weeks, I can't ask you to do in 3 hours. That's unreasonable. Well, I mean, ultimately, the goal at the end of the course. Let me just pull up the course outline here. Document. Ultimately, I mean, there's a series of, just coming back to your question, there's a series of learning outcomes from the course, right? So to earn your credit, you need to demonstrate that you've mastered a series of learning objectives that are part of the course. So in terms of me taking it easy, it's not really a question of me taking it easy or not. If you can't earn the credit, then it's best to repeat the course, because the next course, ASP.NET, it's more difficult. So we don't want anybody going into the ASP.NET course if they haven't mastered the fundamentals of web development with PHP, because PHP is a lot simpler, right? So the exam is really based around the course learning objectives. Tyler, that the college has announced, yeah, that is the plan, is that our program, both web and computer programming, those programs are going to be hybrid in the future, meaning that those courses are largely in person with an online component. So what that probably looks like is that largely we're on campus, and there will be a few lessons, probably about 30% of the course online. So a few weeks, and those will be announced ahead of time, a few weeks will be scheduled as online lessons. So that's sort of the basic format for September, is assume that most weeks are on campus, but there will be a few online lessons. Yeah, Sarah, you can ignore that. The only other two things we have are a quiz, so there is a quiz on this week's lesson that's due Sunday night, and then our final exam. There's nothing else. So anything else you see is old and you can ignore. Okay, any other questions about the exam? Okay, so let's jump into APIs. As I said, this is the first time we're going to work with them, but it's far from the last time. So APIs are a critical thing that all developers, particularly web developers, need to know. How would you describe in everyday non-technical language what an API is? If tonight at dinner your family or roommate said, "What'd you do in your Monday morning class that you got up for?" And you said, "Well, we talked about APIs." And they said, "What the heck is an API?" How would you explain it in everyday language? What is an API? Anybody want to take a stab or make a guess at? You've probably heard this term before. What does it mean? Okay, I mean, yeah, it's a way of feeding websites from other services. That's one example, yeah. Tyler says it's like a special way to access an online program or tool through code. Yes, that's true. So here's the way I like to, what we're going to do, I'm going to give you a quick overview. These slides are here on Blackboard for you to review. Sarah says, collection of information you can use to access on a website or in a web app. True as well, okay? So the actual name, which is really old, is an application programming interface. We'll talk about where that name comes from. It's a really old Windows term. Here it is. Here's my best definition in a simple language. An API is a way for two different programs or applications to communicate. So all of the examples that you put in the chat, all of those are examples of APIs. Now, APIs are not only for web apps, they're for any two types of applications to be able to communicate. So we use APIs because they let us extend the functionality of our own application. They let us include existing functionality from other applications. So instead of us having to write all the code for a certain feature, we can often find an existing API that already has the feature we want to use, and then we can include it in our own application, whether it's a website, a mobile app, or something else. So what would be some specific examples? Let's think of web apps. What are some common APIs we might use or you might see that are integrated into web applications? We see it all the time. What's a common API that we see integrated into many websites? Okay, Google Maps is a great example. If we want to show locations and mapping services, we're not going to build our own map. We're going to make the call and retrieve that information, generate the map from Google. Great example, Sarah. What are some other really common API services that we use? Absolutely. That's great, Tyler. So using a social media channel to log in, right? Rather than writing our own login, we can simply leverage, we can borrow and use the login service from something like Facebook, Twitter, Google. Yep. We even used it, we saw when we went to our Miro whiteboard, right? We could log in with our Microsoft Office, our single sign-in account from the college. If we go to, actually go to the Georgian site, let's go to the college site. Let's say we search here for, search for our good friend Scott. So this page is using an API. What API is it using and how can you tell? That Georgian did not code this page itself. It's using an API instead. Come in. Come. Yeah, that's right, Hamid. How can you tell it's using the Google engine? It's using the Google Search API. How do you know that? You're right, it is using a Google search. Yeah, well, tells us that it's branded as Google at the bottom, but it even looks like, at least an older version, yeah, the style formatting is the same. So most web applications use some form of APIs. So these are simple examples where we're including third-party services, right? So here were some other things that I thought of. So Google has a bunch of services. When we do credit card authorization, we don't charge the credit cards ourselves. We use the API from a credit card service. So we collect credit card information from our shopping cart about what the customer is buying, but we send that information to an API. It processes the charge and then sends back a response. We might use an API to generate graphs and charts for things like web dashboards, or any websites that are showing real-time data. So something like a stock ticker or a news feed. So we might see one here, for example. A little early, but this ticker that updates automatically. So this would be using an API service to show the latest stock prices in real time. Right? The Globe and Mail, it doesn't have that data itself. It simply fetches this data in real time. Here's another really common example. Right here, we've got this little weather. This is going to be up to date. We're actually going to include a little widget like this in our website today. So it will get our current location, show us the weather conditions and temperature in real time. So the term API, it's a really old term. Comes way back from about around 1990. So here was the origin. So when Microsoft originally created Windows, they created these little programs called things like print or save. And the idea was these programs were like a code library that could be used by all the different programs that ran in the operating system. So if you created a program like Notepad, it meant you didn't have to write your own methods to save a file or print a file. You could just use the print or save API that was part of the Windows operating system. So the idea of this was that an API was a reusable small program or method that could be used by other programs to reduce coding duplication and save time. So Microsoft called this an application programming interface, and we've kept that term API to include all of these other things, all of the ways that we can integrate some functionality or share data between two different applications. So this is a neat little video that another computer science professor, it's a few minutes, the link is in the chat. I suggest you may want to watch it on your own time, gives you a little more background of where this term came from. But it's not, APIs aren't only about extending functionality. So far, most of the examples we've looked at, it's about, we can add, rather than write our own search on the college website, we can just use the Google search. Rather than write our own login, we can just use, Twitter login. A lot of APIs are really around data sharing. So there was it showed one example here, something like a stock ticker, right? So the Globe and Mail is showing real-time data that it's fetching from another application through an API. So data sharing is especially common in the business world when we're talking about dealing with online commerce, online transactions. Can you think of any examples of APIs, any other examples of APIs that might share, where we might share data between applications? I already gave one example of, for example, credit card payments online. We build an e-commerce site, we send order information and credit card information to a payment service. It does the processing and sends back some kind of response. How else or where else might APIs be used to share data between applications? A shopping application, right, where we're tracking orders across multiple websites. Absolutely, that's a great example. What about let's think about a single e-commerce application. Think of a site like Amazon, for example. Um, what kinds of data sharing would an e-commerce site like Amazon need to do? What kind of partners or other businesses would Amazon want to share data with? So if we buy something on Amazon, what other companies might need access to that data? This is kind of related to what Sarah said. Right. So that's right, Daniel. So if I have a company and I have a store on Amazon, Amazon takes the order. So if Daniel buys something from my shop and buys it through Amazon, Amazon needs a way to send me that order, right? So that I know that Daniel's bought something and that I need to produce, take out of my inventory. So I'm going to have to build an API that Amazon can send that order to me. And then once I package up that order, how am I going to get the order to Daniel? We're going to need another company involved in that process. How am I going to get that from yeah, that's right. I'm going to have to send it to a shipping company, right? And then how is Daniel going to know? How's he going to track that order? There's some data from the shipping company that Daniel wants to be able to see in his Amazon customer account. So how is that? How does Amazon going to get that tracking number from UPS or FedEx or Purolator? You got it. So then Amazon's going to have an API. So we might have three companies involved. We have Amazon, we have the manufacturer, and we have the shipping company. And that order and tracking needs to communicate, that data needs to flow between those three companies. So how does that happen? Well, the data gets passed through APIs. Okay? Each company has their own secure application behind a firewall. They don't share one database, but the data can be moved through the use of APIs. So most large applications, particularly in the web world, it's not one single application anymore. It's really a collection of different applications that use APIs to move data back and forth. So if we're going to be professional web developers, we now have to know how to consume an API, how to use an API built by somebody else, but we also have to be able to build our own APIs so that if our own website needs to send or receive data and communicate with other applications, we need to know how to do it. So what does this look like? So this is the architecture of the web and mobile banking app for one of the large 5 Canadian banks. And I'm sure many of you even use this bank and maybe use this website and mobile app. Every one of these boxes is a separate application. And many of them are written on different platforms in different languages. So the way that all of these communicate and present to their customer base one unified system for web, mobile banking, all of these communicate through various APIs. So it seems to us as a customer of the bank, this is one integrated solution, as well as for the staff of the bank. But it's actually about 20 different programs that communicate together. And this is why large organizations need to hire so many web developers, because we need to build not only the individual applications, but then all of the services that exchange data and move data between the different components. Okay, so that's the end of our our lecture. So if I go back to my first question, tonight at dinner, if whoever you're having dinner with, family or roommate says, so you learned about APIs today. What's an API? Do you feel like you could explain what it is in a way they would understand? All right, thank you, Sarah. So really, we're just talking about two different programs, communicating and sharing data or functionality in some way. Where are we? So these slides are here on Blackboard, and that link to this little video, it's a few minutes long, it's worth watching on your own time. Again, the history of where the name, so we've kept this name API 30 years later, but we've sort of morphed, the meaning of it's evolved. So when we exchange data between APIs, like let's say we want to UPS to send us tracking information about our order, there's two kind of standard formats that are used to exchange this information. The old standard was XML. So XML looks like HTML tags with opening and closing tags. And for years and years, this was the standard. And some old APIs will still give you a choice whether you want to use XML or whether you want to use, for probably the last 10 years, the standard has been JSON. JavaScript object notation. You guys have probably worked with JSON in your client-side JavaScript class. I assume JSON is not new. So JSON is kind of the new standard. So most of these different APIs and services we've talked about, so for example, we want to use Google Login, we're going to send our request in JSON to Google, and Google's going to send a response back in JSON format. Anybody have any ideas why JSON is now the standard as opposed to XML? Both work, but JSON has a few advantages. Okay, well, they're both pretty flexible, I would say. JSON has objects. Yes. Which is easier to read? Actually, Sarah, pretty much any language could read either of them. Yeah, JSON, first of all, it's a little easier to read. So this is the exact same representation. Which is actually more characters, the JSON or the XML? Which file is longer in terms of the number of characters? Hamid is right. The XML file is actually longer, it's more characters. Why is the XML file longer? There's a simple reason if you look at the format. Right, because in XML, every tag is repeated with a closing tag, like in HTML. In JSON, we only have the key once. It doesn't get repeated. So why would this matter? Why is having a smaller file valuable? The XML file works, but there's less text in the JSON file, and over time, this is a big deal. That's number one, Sarah, the JSON file. If the file is smaller, it's going to execute faster. The other thing is, sometimes these JSON files are huge, right? We might have millions of records in here that we're transferring, for example. And that also affects our bandwidth and our hosting costs, yeah, because of the size. So the smaller the file, the faster they execute, and the lower the data transfer cost. So for those two reasons, JSON has sort of overtaken XML as the standard. So doesn't matter if we've built a website in PHP and we want to exchange data with a web application that's built in ASP.NET, we can use JSON or XML to send that data back and forth. Okay, and we're going to use JSON a little later today. So I've put up a couple of other resources here for you. I'm not going to go through them. So here is the video about what is an API. Here's another little tutorial. So a little simple online course about creating a really simple API. It also includes authentication. So it explains how we can secure our APIs using keys. So nice little resource here if you want to read more about them. So for starters, we're going to do the world's simplest API integration. We want to add a little weather API, a little weather widget, just on our homepage. So let's open up our website. Let's get connected to the VPN. I'm already connected. And I'll start up my Apache server. And we'll open up our PHP Flix project. And make sure we can open it in the browser. Tyler, once the project's already open, you can do File and Open Folder. But in Windows, I think I added it to the context menu when I installed Visual Studio Code. There was an option. During the installation, there's an option that says Add Open with Code to the Windows context menu. I'm sure there's a way to do it. That's for Windows 11. Maybe try this. Yes, it is very helpful. Here's a couple links you can check. You should be able to find it. You may just have to search a little bit. So what we want to do is we want to add a little weather widget. I guess we could add it to the header. So it appears here, kind of like it does on Barry today. So let's open up our header. I was going to just put it on the home page, but I think we can try it in the header. So we'll go to our includes and open up header. And there's a link in the lesson 12 folder to weather widgets. So let's open up this link. And these are widgets, so these are little APIs. I'm not exactly sure why it says I'm in Forest Hill, Ontario, but so I'm going to pick Barry. Yeah, pick anywhere you like. Maybe you want to be somewhere else, right? Maybe you want to be in, let's see, what's the weather in San Diego? Paris, Ontario. Awesome. My daughter's going to Paris, France this weekend because she's in England for school. She's on Easter break. But I will stick with good old Barry. Or pick your hometown. Now, a lot of these are quite big. I just want a little guy. Something like find a widget you like. I think I'm going to pick this one here. And it says get HTML code. So I'll just click. And then it says, hey, click to copy. I'm just going to copy that. And then I'm going to go to my header. And on line 31, this is where we've got our right side nav bar. For the moment, I'm just going to paste it in. We may have to move it. I'm just going to paste in my weather widget right there inside our right side nav bar, and let's see how it looks. So this is before we print out the links on the right side. Save that change. Now I get my current weather. So pretty simple. Now whatever page we're on, we get the weather showing up. So how does this API actually work? And we'll see maybe through the class, we'll see if my weather changes at all. So again, pick any of the widgets that you like. Probably want one that's not too tall, however. Maybe I want this one, it's a little bigger. So this one was only 30. Or maybe I'll try a different one. I'll go get this one. Try that one instead. So play around, find a weather widget that you like. I think I like that one a little better, a little easier to read. So really simple integration. We're not calculating the weather coming up with the graphic. So how does this work? Well, it simply links to the book.net website with the city I've entered, and it generates an image for us. Okay, so this is kind of a static API. It's not dynamic because I'm going to update in real time. But some APIs are as simple as a copy and paste. So that's all we've needed to do here. So pick a widget, pick any location you like, and you can display the weather here or in your home page, wherever you want. We also want to integrate a Google API. And this is not, we're going to use Google APIs in future classes as well. So next semester in ASP.NET, we're going to want to implement Google Sign-In. But I also want to add an implement. I'm not going to do Google Sign-In here, but there is another API we might want to add for security on our registration page. So whenever we have public forms like this, Google offers an API to help keep spam and bots from automatically submitting our forms. What's the name of that API? Yeah, it's a CAPTCHA or Recaptcha code. So what we want to do is we are going to add Google Recaptcha to our form. So let's go and have a look at. So here's the link to Recaptcha. So Recaptcha kind of has a bit of an interesting history. So it protects our site from fraud and abuse. And the new version, the old versions of Recaptcha used to be kind of cumbersome, where you'd have to, type text, and then it was identify pictures, which Google used for Google Street View and Google Maps, but it's become frictionless now. So the new version is all algorithm based. So many sites now with Recaptcha will just see a little Recaptcha logo, and that API works in the background. But users don't actually have to do anything. So it uses artificial intelligence to analyze every customer and bot interaction, and it will decide whether we are a human or not. So the old version, something like this, where you have to check not a robot and identify pictures. And now we're on to this version where it will just use AI to automatically score our attempt. We're not going to be using enterprise. That's a little bit of overkill. We're just going to use version 3. So the first thing we've got to do is set up. So you're going to need a Google account to sign into your Google account for this. So I'm just going to use Chrome, where I'm already signed in. So use the link that's on Blackboard. The Google Recaptcha anti-spam for forms. And we're going to click on any Google account will work, Tyler, as long as it's a Google account. It can be personal. I mean, your Georgian accounts are not Google accounts unless you are using. If you've tied your Georgian email to your Google account, then yes, it will work. So then I'm going to go to the version 3 admin console. So what we need to do is we need to register a new site. So I'm going to click on the plus button here for create. I've got to name it, so I will call it PHP Flicks. We're going to pick version 3. So Google will score the spam attempt automatically. We don't have to get the user to verify requests. We then need to add a domain. Now, it will automatically work on localhost, I believe, but we will need it to run on computer studies when we upload our code to our AWS server. There's our domain. And then just accept the terms of service. I'm going to uncheck this. I don't need Recaptcha alerts. So I don't need it to email me. So just give it a name, Recaptcha 3, and our domain is computer studies. And we'll submit. I get a message saying my application's been registered, and it gives me 2 keys. A site key. This is going to get integrated into our register.php form, and a secret key that's going to go into our save registration page. And then there's links here to see the client side and server side integration. So I'm going to click this see client side integration. So that takes us to the documents. So it returns a score, tells us we need to register our keys, which we just did on the previous page. Where to put it on our site. It will never interrupt our users. We recommend integrating it on forms. So the first thing we need to do is we need to add a link to the Recaptcha JavaScript on our register page. So under this here, automatically bind the challenge to a button. It says to load the API. So I'm going to copy this. And we're going to go and open our register.php. So I'm going to paste in the link. So we're making a call to this Recaptcha API library from Google. That's step one. So paste in that script below our register form. We'll go back to the documentation. Step two, is we're going to add a script that when our form is submitted. So let's copy that, and then we're going to have to make a little change to our HTML. So we'll copy that. We'll paste it in. I'm going to change this demo form here to register form, and then we need to give our form tag this ID of register form. We're going to change demo form to register form. Scroll up to our form tag and we'll give it an ID. ID equals register form. So this matches the ID in our JavaScript. That was step two. I've added this ID to the form. And then we'll go back to the Google Docs and we'll read our next step. So it says we want to add some attributes to our button. Now we've already got a button. I'm going to copy these three values: the data site key, data callback, and data action. I'm going to copy those into our submit button, and we'll add the Recaptcha class. We already have a class attribute. So copy those three properties that start with data. The site key, we're going to put in our Google key, our callback, and our action. In our button here, I'm going to paste those in. And I'll also add the class of G And now we need to replace this site key with the key value that the Recaptcha console gave us. I can load my form right now, but I'm going to get an error saying invalid site key. So if I go and look at my form right now, we can see I get an invalid site key. So it's trying to generate a Recaptcha, but it says the key is not valid. So if I go to my first tab here, here's my site key. I'm going to copy this. And I'm going to paste it in here. I'm going to take out the text. This is just a placeholder, this Recaptcha site key. So I'm going to paste in my own site key here. And now if I refresh, it tells me, okay, so that error is gone, but it says localhost is not in the list of supported domains. So we'll need to add, didn't think we needed localhost in our domain, but we do. That's okay, we can fix that. And then we'll take a break. I'm going to go to my settings, and under domains, I'm also going to add the domain of localhost. So now we've got two domains, our live domain that runs on AWS and our local domain. They should both be allowed. And if I refresh, now we can see those errors go away. And it says our form is being protected by Recaptcha. So again, we did 4 things on the form on our page. We copied the link to the API JavaScript. We copied this little script from the documentation, and I changed the word demo to the word register. I then added this same ID of register form to our HTML form tag. And then we added the data site key, the data callback, and data action. Again, I just copied and pasted this. So typically when we're working with APIs, we have to read the documentation. We have to read the instruction. So we've been going through this section, automatically bind the challenge to a button. So copied, copied, copied. And then we've just replaced the site key with the site key that we generated in the Recaptcha console. And the result is we've now got a Recaptcha being displayed properly on the form. Now keep in mind, this isn't complete. We'll still need to validate, we'll need to verify on the server after the user submits. We'll need to check that the Recaptcha score is good. Tyler, you don't need to go to Google Cloud. You can just use this link here, the Google Recaptcha Anti-Spam for Forms. Click on that link. It will take you here. So it takes you to this page. You then click the version 3 admin console link here. And then you can create your site. So when you create the site here, it will generate the keys for you. Okay, we don't need the Google console. Okay, it is 8:55. We're going to take a break here. When we come back, we're going to have to look at the server-side integration that explains how we verify the response, we send a post method to Google, and we will then get a JSON object back that we'll need to evaluate. So we'll do that, and then we're going to build a really simple JSON API of our own. We should be able to do all of this within an hour. I would hope that we're done by around 10 o'clock today. Okay, I'm going to upload what we've done so far to GitHub. Let's take a 10-minute break. We'll be back.